Hello everyone, you're welcome to this week's Tech Tuesdays webinar on MDM Federated Architecture Options. I'm Brinda, your host for today's session, and we have with us Dilip Yelaguri, Principal Customer Success Technologist, and Shaurya Das, a Solutions Architect, who will be presenting for this session. Before we start this webinar, let's go through some housekeeping tips. The webinar is for 1 hour that includes a 15 minutes Q&A. You can post your queries in the Q&A box. All dial-in participants will be muted. The session is being recorded and will be available in the Informatica Support YouTube channel and the Success portal. You'll also be able to download the slide deck from the Success portal. Please feel free to put in your feedbacks and suggestions for the session in the post-webinar survey. The Tech Tuesdays webinars are hosted within the Success portal, which is a micro-learning platform that offers free and unlimited learning to all registered users. This feature-rich platform was launched to help you learn and use Informatica products better. Here are a few important links that you can go over later that will help you in your product adoption journey with Informatica. Over to you, Shaurya and Dilip. Thank you.
Hello, everyone. Very good morning. Welcome to today's Tech Tuesday session that will be presented by Dilip Yelaguri and myself, Shaurya Das. Both of us are part of the customer success team of Informatica. Today, we're going to discuss the best practices for a distribution of MDM that you might find beneficial in your current project implementation. And it is also valid for other customers if they are looking forward to implement MDM in their technical landscape. So today we're going to discuss a couple of agendas. Number one, which is the mastering across countries and or business units, and the distribution and federation of MDM hubs. Now, with the growing size of businesses and our customers, it has become critically important to master the source system data coming from across various source systems, of course, right? To master them. And when you master them, not all the data resides in one singular geographical location or country, right? Maybe it's across the US, Canada, Mexico. Some customers have data across EMEA, Europe region, right? Middle East, JPAC. So it's very important to understand the data privacy laws, how you can optimally achieve a good federated MDM, but at the same time master them together harmoniously. Also, we'll talk about the distribution and federation of MDM hubs, how to set up those MDM hubs, what are the different options of setting up those MDM hubs, and how the distribution and federation, what are those challenges and how to achieve them. So let's dive into these two agendas today, and we'll discover more as we go along. So as discussed, the part one of this presentation talks about the considerations for mastering across business units and national borders. So what are the different federated hub considerations that you need to make before drilling down to a choice of which approach or which technical design you should follow? Let's look at some of them. So definitely determining how the data is to be consolidated, right? Domains are completely independent. So maybe you don't want any clubbing of the domain data. For example, you might be mastering suppliers, products, parties, employees, customers, right? So it's definitely important to understand what is the level of consolidation you want to do, or maybe you want to do some tight coupling between the suppliers and the customers to find out which customers are suppliers, so that sort of thing. Also, we need to take a look at the address compliance and physically assess those concerns, right? For example, the data residency, GDPR, CCPA, German Employment Council. These are some of the new data privacy laws or data privacy regulations that are in effect today, and we need to consider them very carefully to understand where the data needs to reside. Can the data reside in other geographical locations or countries, or does the data of a particular country need to reside in that country itself? So we need to take decisions based on those, right? Think about the hub management, central or local. So if the data will be segmented geographically, governance of the data must also be segmented, right? So for example, if you have data belonging to the United States of America and you have data stewards from the US, right? You would essentially want US stewards to govern the data belonging to that particular region, North America, right? Now, for example, if you have data from Germany, you would essentially want German data stewards of your belonging to a particular customer, right, to govern the data, take any governance decisions that come out of that data, right? So we need to think about the hub management. We need to identify synchronization and correlation requirements. If the data will be segmented geographically, coherence and correlation requirements must definitely be addressed to understand how you want to design the data, right? How they want to be correlated, even though they are geographically separate, right? You have any business processes, existing business processes, right? Which might be dependent on other regions as well. So you need to think about from that perspective. Design for non-invasive use of data from existing hubs, and how to design to make additional domains easy. So these are the different federated hub considerations we need to discuss with the internally with the customer or with the business, with the stakeholders, with the technical architects to come to a correct conclusion of which design is going to be suited best for your MDM implementation. Continuing on the federated hub considerations, we also need to determine the need or desire for a common core data model. Determine if regions need different attributes to support the same domain. Now, this is very critically important. For example, if you're doing like a supplier master, right? Based on certain attributes which are business sensitive or critically important in a particular region, let's say Canada, right? But the same attributes for a supplier might differ what you have in Japan, right? Based on the business process or the way the file format or the supplier template is set up. So we need to come to a common understanding of a good, robust data model and take into consideration how these different attributes, which are geographically, important or have geographical flavors to them, how we can support them together. We also need to identify internationalization requirements. Are there going to be any BU-specific or country-specific data model extensions? What are the different reference values or lookup tables based on the different countries? Do you have a language matching rules? For example, when you're matching data based on the US, of course, you have a particular population file. But if you want to match the data that your customer or organization has, let's say in Australia or Indonesia, right, you would have to take into consideration the different languages, the different matching rules, the different population files, or maybe you want to match data in Mandarin, right, for the data coming out of China. So you need to take into consideration those different sets of requirements so that you have good match pairs, you have good master data at the end of the day. We also need to look at the system interfaces and the external sources who are supplying those data that you want to master. And we need to determine if additional use cases will need to be supported. So as you can understand, there are some varying factors when it comes to federated hub consideration or conclusion, and we need to think holistically from all these data points to come to a good understanding and choose whichever model suits best. What are the hub synchronization considerations, right? So one of them, of course, is the frequency and timing of central to local hub synchronization. Another, of course, is queuing of local updated and new records for central stewards approval conflict resolution. Because in any data governance or MDM project, you would have a group of central stewards, right, who always play a very, very important part in approval and conflict resolution of matching data, data approvals, data updates, new data inserts. So it's very important that we take that into consideration. Also, provide local visibility to history lineage of Central Hub and provide the tools that help build or design these local hubs from the central hub, right? So you would essentially have one single central MDM hub, and you'd have multiple local hubs as well. So we need to kind of understand these synchronization considerations. Now, you might ask, how do I understand these answers, right? Based on our extensive experience, we always kind of try to figure out by talking to the business stakeholders, business process managers, based on this across this spectrum of different geographical locations, to come to a valid understanding of what should be the hub synchronization considerations or requirements rather, right? What are the use cases that will support this design that we are choosing? So it's critically important that we spend a good amount of time discussing this internally with the customers and within the organization as well to come to a common understanding. There are some policy and governance considerations as well. So let's look at those. One is definition of common sources and shared core customer attributes for sure, right? One is the definition and management of reference data. One is the definition of process for sharing and synchronization, data governance roles and needs, establishing of the trust framework, definition of process for local master data management, and what are the workflow requirements. Now, let me just expand on these points a little bit. Now, definition of common sources and shared core customer attributes. When we define what are the common sources, right? For example, let's say SFDC might be a common source for your organization across the globe, right? But there might be specific sources which carry specific geographical data in specific countries, right? Those are not universal sources for your organization. So in that case, we need to understand what are the policy or governance or regulations for that particular source. We need to define the management of reference data, of course. Reference data is a very tricky part, but it's also a very important part. Generally, what happens is whichever domains you're mastering, or if you're mastering multiple domains as well, reference data tends to be different for different countries. You would probably have a subset of universal reference data, but at the same time, you would definitely have region-specific flavors in that reference data, right? So we need to define those, consolidate those, manage those, and filter out, come up with the best breed or best set of reference data that we can trust across the different geographical locations. We need to also define the process for sharing and synchronization, like we were discussing in the last couple of slides. Data governance roles and needs. Now, of course, with any MDM project, right, data governance is a process. It's critically important to govern the data, to keep tabs on the data, check the profiling scores of the data, right? See how the data quality is improving overall. So all of those requires different roles and needs that people need to play within the organization. So we define those data governance roles, give them necessary privileges, and set the expectations correctly. Establishing of trust framework. Of course, if you have multiple sources in multiple countries, you would need to trust a particular source more than the other source, right? When it comes to certain business attributes. So we need to come up with a consensus for understanding that, okay, I trust these attributes or columns more than these attributes for this particular country, so that ultimately the trust framework is going to play a very essential role in matching of the data, right? So that's where we need to take this into consideration. The definition of process for a local master data management, right? When we are mastering the data locally, not centrally, right? Locally, then we need to, for example, let's say we are doing one mastering for Asia Pacific, one mastering for Latin America, one mastering for North America, and let's say we're doing one mastering for EMEA countries, right? Europe and Middle East. In that case, what happens is that all of these master data now will flow into the central hub, the universal hub, right? So you would have a set of rules or processes for the central hub, but having said that, at the same time, you're going to have multiple different processes established or rules established on how you want to master the data coming from this individual APAC, Latin America, North America, EMEA hubs, right? So you define those matching rules. So it's we have to take a look at it, in an isolated manner as well, and in a holistic manner as well. So what I'm trying to say is that you need to compartmentalize the local hubs, define those, master those, and then the mastered good quality data from those individual hubs, like 3 or 4 different local hubs, are going to flow to the central hub where you're going to store the data, which is basically coming from all over the globe, right? And master them again if necessary or if possible. So that's how we're going to, but we're going to look at some of those diagrams as well going forward. So no worries. And of course, you would definitely have workflows, right? ActiveOS workflows to manage those roles and privileges of those different roles. You would have data stewards at local hub levels. You would have data stewards at central hub level. So you would have good, robust workflow requirement. So let's move on to the next slide, and we'll see how all of these that we have been discussing translates into some technical hub designs. So let's take a look at part 2, which is our federated architectural options. So one is the MDM reference architecture for approach 1 and approach 2, right? If you take a look here on top, we have option 1A, 1B, 2A, and 2B. Now, bear with me here a moment because we need to go through these carefully and understand. So option 1A talks about single ORS, single data model. This is, of course, as you can understand, the most simplistic model, which is basically for, very simple use cases, not too complex data requirements, not too complex data regulation or privacy requirements. So this is, of course, a very simplistic federated hub architecture. Option 1B talks about single ORS and multiple data models. You'd probably have one single ORS and you'd have multiple data models based on the different, like I was saying, geographical requirements. One is 2A, which is multiple ORS and single data model. So you would probably want to have multiple ORS where you want the data to reside in different geographical locations, but still you would want to stick to one single data model. You probably wouldn't want to go for multiple data models and make it more complex. And option 2B is for more complex use cases where you have multiple ORSs and multiple data models. So this is, of course, a little bit more complex to manage, but a lot of customers have those requirements as well. So if you take a look at on the left side here, right, you'll see the source systems, and then you see the data integration layer. So the data integration layer is essentially where all these sources are brought together, consolidated, they go through the data quality process, we filter out the bad data, right? So it's kind of the first entry phase into the MDM ecosystem or the world of MDM. And then, of course, the data flows into the enterprise and functional MDM. You have the enterprise data stewards and the functional data stewards who work on these enterprise and functional MDM data. And then you have another data integration layer where you build out your REST web services or your message queues, all the way you want to publish the data to downstream systems, and they flow over to the business applications native to your organization eventually, right? Be it a SAP, SFDC, call center, whatever UI you might have out there, right? So this is where we need to understand that, okay, for a single OR, single data model, like I said, all the source system data come in, they go, we master them in the enterprise and functional MDM, and it flows out. Now, of course, for multiple ORs and multiple data models, what would happen is you would have multiple ORSs residing in different geographical locations, and as well, you would maintain those multiple data models, right? Tag them to different ORSs based on your geographical locations. Now, you would definitely have enterprise data stewards and functional data stewards for these different ORSs and different data models attached to them. So different set of data stewards for enterprise and functional MDM, right? Now, when I say functional MDM, maybe it's but when you're doing an MDM, let's say for USA or for Canada separately, right? And what the enterprise data steward would do is kind of sit at the top of all those, right? And manage the entire set of data, maybe in the multiple ORs, multiple data model, the option 2B use case or option 2A use case, where the enterprise data steward would have visibility to all the data sets, right, across the ORS and data models, so that they can take a correct informed decision on the global data. Uh, let's talk about an example for this. So we have a large international logistics company. So you have the contact systems in America and EMEA. You have the contact system in Asia Pacific as well. They have worldwide customer data, which is managed centrally because it was deemed essential for the business. So you have like a central data quality hub where you build the data quality rules, you build a data integration layer, and then you would have a central MDM hub. Now, as you can see, we have some local hubs as well, which is multiple ORS, and then you would have a centralized hub. The data then flows back to the contact systems, downstream consumers. They create reports out of it on a weekly or daily basis. So you would have stricter controls on the publication of the data, as not all users were deemed essential for the business. So basically, like I was saying, you compartmentalize the data, give access where it is required. So the local data stewards would not have the visibility or access to the data that an enterprise data steward would essentially have, right? So it's basically a single domain, a single instance of MDM and data quality, a very large infrastructure, all data available in English, and no local specific mastering was required. But so basically, this is kind of a very, like I was saying, a simplistic use case, but of course you would have different sets of roles and privileges here. Uh, let's look at the distributed hub options, summary of it, right? So approach one was a single hub instance with single repository, and we would have option A, single data model per repository, and option B was multiple data models per repository. So let's for 1A and 1B, which if I go back here, you'll see which was single ORS single data model and single ORS multiple data model. So what are the different requirements based on which you take this decision, right? So for example, if you had a common data model, local specific configuration, privacy laws, common data model, relationship across entities, relationship across subset of entities. If you had these sort of use cases, you would go for this kind of a requirement or this kind of a distributed hub option. So that is the purpose it would solve. Now, another example, a large international energy company, right? So you would have asset data, location data, customer data, you have central data quality, and then the data flows back to the ERP systems, downstream systems, operational reports. So you would essentially have multiple domains, but with no data residency requirements as such. So when I say multiple domains, customer, employee data, maybe mastering, supplier data, product data, again, you would have single instance of MDM and data quality. You would have multiple data models, of course, multilingual, right? Domain-specific mastering and local-specific mastering. Let's take a look at the distributed hub options of the summary for 1A, 1B, 2A, and 2B, right? So 2A, 2B, if you guys remember, it was a single hub instance with multiple repositories. 2A was single data model per repository, and option B was multiple data model per repository. So as you can see here, for 2A and 2B, the use cases have expanded. So now we are covering local specific configuration for permissions, privacy laws governing protection of data, regional level data management, local specific workflow, local specific lookup tables. So all of these are covered by 2A and 2B. So like I was saying, it all comes down or boils down to your different use cases and requirements. Now, how would you understand these use cases and requirements? That is where we covered in the first 3 or 4 slides, right? The considerations for a distributed and synchronized MDM. Based on all those use cases and policies and discussions, you would come to a common consensus and important understanding of which design you should go with, right? So having those discussions within the organizations is absolutely important and critical to selecting the correct hub options, because when you select the correct hub option, it makes life easier for everybody, for MDM, for data stewards, for downstream systems, upstream systems, and you get the best purchase to value in your project implementation. Moving on to the next slide in our presentation, we would have a closer look at the reference architecture for more options and what are the different advantages, disadvantages, or what are the different use cases based on which you would go for the other reference MDM federated options. But to take this forward, I would hand this over to my esteemed colleague, Dilip. So Dilip, take it away from here, and thank you for giving us the opportunity to present this.
Thanks, Shaurya. Hello, everyone, and thanks for taking time to participate in our webinar. As Shaurya mentioned, that these architectures are best suited for various organizations with different requirement considerations, and their use cases. Now let us understand another reference architecture. In this scenario, we have two groups of data stewards. We have enterprise data stewards and functional data stewards. Similar to previous architectures, we have multiple sources and consuming applications, and they are being routed or orchestrated using the data integration layers. Once the data is in MDM through these data integration layer, the data stewards and regular MDM capabilities are used to master your data, and then once the data is mastered, it's sent out to your consuming applications. The critical difference between this option approach 3, option 3A and 3B versus the previous options is that we are having multiple types or groups of data stewards, and they are managing your enterprise data as well as your functional data. But in this approach, there are two options, 3A, where you can have single data model, or 3B, where you can have multiple data models. So let's understand the entire architecture with the help of an example. So let us take a large European bank as an example, where they are mastering their customer data. And this entire customer data is routed to MDM via the central data quality, which is part of the data integration layer that we have seen in the previous slide. And then once the data is routed to MDM, there are various segments of MDM, and these segments could be based on geography or language or other considerations that Shaurya has mentioned in the previous slides. So once the data is into these different segments of MDM, these are various segments, but are all still part of the single domain, which is the customer domain. If the data is consistent on the structure from all these segments, then we could have a single data structure. But if the data is different, either based because of the geography or the language or the type of data set that is coming in and being mastered, then in that case, you can have multiple data models. And as we are talking in this example as a European use cases, there may be multiple different languages that can get involved, and that's the reason we could have multilingual use case in here. And the moment you are talking about multilingual use cases, the data set is different, the character set is different, the population files are different, and hence the match and merge logic, first configuration could all be different, and that could also drive multiple data models in these different segments. But once all these different segments are used to master your data, you have all these multiple MDM instances, but these can be considered as like silo MDMs, and all these silo MDMs are individual segmented MDMs, and they are probably targeting various systems in your company. Some of them could be helping your ERP system, some of them could be any other consuming system, or they could also be helping with your operational reports. So this is example, but just to summarize these two options with respect to the use cases, requirements, and their approaches, let's go over again. And this time we are going to look at all the approaches right from the first option till now. So in this particular approach, we are having a single repository, but we can have multiple hub instances. So and within this particular approach, there are two options, which is a single data model per repository, and the other option could be multiple data models per repository. And when we are talking about these approaches, this primarily helps with these kinds of requirements where it is like country level data management, where you have a requirement to adhere to privacy laws governing physical locations of the data, could be like an on-soil requirement. It could be staying active in a region and inactive in another region, or it could also have some kind of requirement around the locale or languages and their user properties. So if these are the kinds of use cases, you could go with either 3A or 3B to fulfill these requirements. But if it is very simple, like the single hub instance with a single repository, you could go with or any other such variations, you could go with the options 1A, 1B, 2A, 2B. But if you have additional requirements that require these requirements like these, you could go with the options 3A and 3B. So moving on, so there is the next three architectures can be called as hub of hubs. So we have seen various progressions of the architectures, and now this is another variation where we usually call it as hub of hubs. And we have three different approaches to the hub of hubs. And let's start with the first one, 4A, which we usually call as registry of hubs. And in this particular registry of hubs, we are basically addressing the silo independent segmented MDMs that we have seen in the previous option. And if there is a use case or a scenario where you wanted to have another enterprise MDM that will basically integrate all these silo MDMs into an enterprise MDM, and you don't need to capture the entire data, but you're just trying to create a registry, that is when you could come up, you could use this particular approach 4A, where you're building a new enterprise view of your master data, and it's a registry style where you're just storing the IDs, and these IDs are passed on either by ESB or any other mechanism that gathers the data from your individual segmented MDMs and push it to the registry MDM. And this could be one approach to handle the hub of hubs. And the next approach would be we usually refer to this particular design as a subset master hub. So let me explain the entire architecture through. So you have the source systems as usual that are integrating and that are being supplying the data through the data integration layer, and the data integration layer supplies the data into your enterprise MDM, which is a superset of master data. This contains all the information across your organization. All sources data comes into this enterprise hub, and then once and you have your enterprise data stewards governing this enterprise master data MDM. And once your enterprise MDM is set, the data from the enterprise MDM is passed on to the segment MDMs that will capture very specific segmented data, similar to some kind of a data mart kind of analogy, where you have a data warehouse and then you have required subsets of data marts helping certain very specific business applications. So similar to that, you could have an enterprise MDM governed by enterprise data stewards, and then that master data, the superset of your master data, is broken down into segmented MDMs, And you have segmented data stewards that are governing the data within these individual segments, and they help individual applications that are focused on certain functionality. So the next approach we refer to as a hub and spoke model. So this is almost the same, but it is slightly reversed, wherein the source systems are actually feeding the segmented MDMs, and you have your data, the segmented data stewards managing the data within the segmented MDM. And there could be some applications that are feeding directly off of these segmented MDMs. And once you have the segmented MDMs created, all the segmented MDMs are again fed to the enterprise MDM. So these segment MDMs could refer to either at a business unit level, they could be segmented at a geographical location level, or maybe an existing MDM solution that has a subset of your data. But once all this segmented MDM is routed to your superset or your enterprise MDM, you are able to create an enterprise level application which is governed by your enterprise data stewards, and then all the information is stored in your superset at the enterprise level. And there could be many enterprise level applications that are consuming this enterprise MDM, and there could be some sources that are directly connected to the enterprise MDM which don't have to go through individual segments, segmented MDMs. So let's see an actual example to understand all these three architectures in detail. So let us consider a huge publisher or a retailer kind of a customer who are handling various types of data, right? So they could have multiple CRMs, and each CRM could be sending in a lot of data. There could be multiple applications that have product data, there could be revenue data, and so on and so forth. And all of these are routing to multiple segmented MDMs, and each segmented MDM could be addressing different kinds of data as well as different kinds of applications which are local, and all these are local systems. And they could be silos, they could be very focused on individual applications. And once these segment MDMs are completed, then the data is extracted from these segment MDMs to create your enterprise MDM. And this enterprise MDM will be your superset, where it has much larger data volumes and much larger, wider data sets, and it could be used to accommodate, or it could be serviced for different corporate systems. And in this particular kind of architecture, the different variations that involve are multiple domains, right? So as I was saying in the beginning, there could be different domains. There could be domains like your supplier data. There could be a customer domain that will capture the customers of this huge publisher or a retail company. There could be a supplier master or a vendor master. There could be a product master. There could be a location master, and so on. When it comes to all these instances could be based either on domains or geographies or both. And when it comes to the data models, again, these data models could again be based on the domains that they're servicing, or they could be based on geographies or even languages, right? So whenever we are talking about an international enterprise that has data coming from multiple countries and multiple languages, that could also influence what kind of data model is used, because different languages can require different data sets, different match rules, different population files, and such. And then your enterprise hub is used for corporate use cases. And this way you are able to see a different variety of architecture use cases that can be fulfilled with this. So just to summarize all these three approaches, let's take a look at this table again and the requirements that these designs cater to. So as before, these are all the requirements that are being serviced by various approaches, and the additional requirements that the hub of hubs is going to accommodate is specific to linking data from existing heterogeneous hubs. Like if there are multiple silo hubs or segment hubs, you could link the data from there. Or if there is a requirement to consolidate from existing heterogeneous hubs, you could use this either 4B or 4C option. And if you have a requirement to keep the master data closest to the source, in those kinds of requirements, you could use either 4A or 4C kind of an architecture. So in summary, there are these three types of hub of hubs. You can do a registry of hubs, you could do a subset master hub, or a hub and spoke model. So these are the different hub of hub options we have. In summary, for all the different approaches, the very first one would be a single hub with single repository where you have one MDM install instance and one ORS. And within this single ORS, you could have a single data model or you could have multiple data models. So that is a very simple approach one. But if you have some other additional use cases, you could go with approach two. And in this particular approach two, you again have a single MDM instance, but you can have multiple repositories. And within these multiple repositories, you can have single data model per repository, or you could have multiple data models per repository. And the use cases and examples we have just gone through. The next kind of approach is basically your multiple hub instances, but all of them have single repository per instance. And even within this, even within these multiple hub instances, you may have a single data model or multiple data models per repository. And finally, the hub of hubs, which is either a registry of hubs where you're just registering your IDs of segmented MDM data, or you could create a subset master hub where you are creating multiple segments and then mastering it, or the hub and spoke model. So this is the final kind of a summary where we can see all the different requirements and the different federated architectures that can fulfill these requirements and the options that you have while you are doing it. So once you have made all these design decisions and created your architectures, then what's next, right? So we have discussed about what are the different considerations that you do depending on different use cases and requirements. And most of the use cases and requirements are basically around different data governance use cases, could be GDPR requirements, could be various other requirements as Shaurya was mentioning upfront in the presentation. Let us take a step back and look at the entire solution, right? So just MDM by itself may not be able to resolve all the different kinds of use cases that we have mentioned. So this is an example where you come across various software technologies coming together to solve this larger problem, where you have all your source systems that are being ingested through data integration and data ingestion processes, and they are feeding into both data governance and data quality applications. And data governance and quality feedback each other based on the types of requirements and cleansing requirements. And once the data is cleansed, you are feeding that data to master it. You could use any of the options that we went through to create this master data. And along with that, you have these other enterprise 360 applications where you are synthesizing the data, you are working on transactional data, IoT data, and you are all these applications are being referencing master data to create a better quality data. And once the data is all prepped and ready, it is ready to be delivered to your enterprise applications. That could be sales applications, marketing, service, data warehouse, and so on. So all of these activities can be done, but on top of it, you have data cataloging feature where this cataloging feature can be applied all across, right from the sources to the targets, and then you can track the lineage and activities going on at each and every step. We hope that this presentation and webinar was helpful, and we would like to open the floor for question and answers. Thanks, everyone.
Thanks, everyone. We can continue the Q&A. So there is one question about how does the architecture changes are addressed along the entire duration of the project. So you don't have to actually fix with one specific architecture all along the implementation. So the MDM is kind of a living and breathing project, and it keeps increasing or growing as the enterprise applications are using it. More use cases come in, more requirements come in. So you may start with a very simple like a single hub instance with a single repository, but as the use cases evolve and there are more requirements coming in, you may start from option 1A and then go to jump to either like a registry of hubs, or you can probably go to maybe like a approach 3A or 3B. So it depends on the requirements, and as the requirements continue, you can basically evolve the entire architecture and grow that architecture based on the requirements. There's another question. Is it necessary to create such a complex setup like this 4B, 4C? Could it be achieved? So the question is about hub of hubs, approach 4B and 4C. The question is that, like, is it required to go with with those kinds of 4B, 4C where you have a lot of individual hubs and you are mastering, like doing hub of hubs? Couldn't we achieve the segmentation of the data in the enterprise MDM by using other ways to segregate the data, or use ORS concept in MDM or any other models? So the reason we have to go with 4B and 4C is when you have specific requirements where you cannot commingle the data. So say, for example, there is a GDPR kind of a requirement where for certain use cases, you cannot mix the data from one segment to the other segment, or one specific MDM area. But there are certain other requirements where for the same company, say there is a European data. So the example that we have previously mentioned, there is an international bank that has offices in Europe as well as in US, just as an example. And the data in the US can be managed by any enterprise data steward, but the data which is related to Europe is not supposed to be viewed or accessed by non-European personnel. So in that kind of a use case, you are forced to go with multiple segments, and the European data is typically managed by the European data stewards. So that way, you had to create a segment MDM, which is very specific to that geographical location. And then there is another geographical location that requires another segmented MDM. But say you have another corporate use case where you need to capture partial data that is GDPR compliant, but you can use it for enterprise use cases. You bring in that acceptable data into the enterprise hub, and any other segment data that can flow into an enterprise MDM. And then you can build any corporate enterprise level use cases off of the hub of hubs. So it totally depends on the actual requirements and the use cases, and who is using the system and how they are intending to use the system. The option 4B and 4C, just because I'm from the traditional data warehousing background, it's more or less like certain architects, they like the top-down and bottom-up data warehouse building approaches. So it is similar to that, the way I look at it. But all of these architectures are totally driven by the use cases and requirements that your organization has. But the critical point being, you don't have to fix a specific architecture right at the early stages of your project, because the use cases evolve, the number of applications that use evolve, and the source systems and the domains that are being mastered can change a lot of time. So there is a lot of time for re-architecting and accepting more requirements and increasing the scope and architecture of the landscape of your MDM implementation. Hope that helps. Are there any other questions? So as we were talking about the architecture, and these are very specific requirements and use cases, but if there are any other requirements and use cases that were not mentioned in the presentation today, and you guys have any more questions, and if you need any additional help, definitely feel free to reach out to us, and we can help you in fine-tuning the architecture very specific to your use cases. So thanks everyone. Thanks for your time and spending some understanding with us, spending your time on a Tuesday morning. So looking forward to more interactions like this in the future. Please share your feedback, and we'll get back to you next Tuesday with a new topic. Thanks everyone. Have a good day.